session. So next, and create user. All right, so this test user now, all right, go to this test user, go to security credentials, all right, access key, create an access key for that test user. Come over here, understand, next, and create. Now this guy should authenticate now. Come to the terminal and say what? AWS configure, right? AWS configure. Paste, then the access key, sorry, the secret key. Let me hide this thing. Paste, region is this same JSON. Now if I say AWS STS gets caller identity, you see that it is the test user that is what? That is authenticated to your AWS account. Now, I want to download the kubeconfig file. I'll say AWS EKS, all right, update kubeconfig -- region is EU West 1. Then name of the cluster is EKS cluster. So if I hit enter now, determine that this guy is updated, right? Now, let's check now. kubectl gets node.
Live. Now it's how it gets.
Yeah. Are you seeing now? So because it is not this user that created this cluster, there is no way this guy can write into this file. Because if you go into this file now, .kubeconfig, I should see, let's check the user. Name is this. Users. Is embedded somewhere. I think it should be embedded in this certificate or something. But somehow, let me check something. Nudi. All right. Somehow it is this guy, all right, the Omero user that has the rights. Okay. So you can see this guy does not have, and it could not get current server API group list. The server has asked for clients to provide credentials. Right? Okay, then you must be logged into the server. The server has asked for the client to provide credentials. All right. So this is the challenge. There's a challenge. So until you authenticate with the appropriate guy who created the cluster, which is the Omero user. So delete this guy. Guys, 1 second, make I update. So go to users, you go to delete this user, delete, test, delete. Go to Omero, credentials, access key. All right, so copy, come to your terminal, AWS configure, paste that, copy this, paste it, and go. So AWS STS gets caller identity is Omero. So Omero now can do kubectl get node because he created the cluster. All right. So great, guys. So this is what we have today. I never open Lucy chats. 1 second, guys. 1 sec. Let me pause.
Where a cluster has been created and want to give access to some of the colleagues that wants to manage the cluster as well. So how do you go about this?
Okay, there is what's it called? There is a config map. Look at now. If I come to this guy now, all right. If I say kubectl, there's an object kubectl gets config map in the kube system namespace. When we shall get to authentication, all right, we shall look at this thing. Now, there's this config map called AWS Authenticate. Now, let's open this file and look at what's in there. Now, look at this guy now. If I do get config map, or if I say kubectl edit config map, short form for config map is CM. I hope I'm recording this session. Is it recording?
Yes, yes.
kubectl, all right, it's recording. So kubectl edit config map. The config map name is AWS authentication auth in namespace kube system. Now, if I open this file, I'll come somewhere. API version, the data, mapping rows, group, system, bootstraps, system node, role and is this, all right? EKS worker role. Then username, system node, EKS private DNS, okay? The kind is config map. The metadata, creation time, name is AWS authentication, namespace is this, resource version, then UID. This UID is the user ID of Omero. I don't know how to get this UID. Now, to grant access, though is what we shall look into, all right? Is what we will look into is simple, all right? I've not gone this route, but I will treat it when we get to Kubernetes authentication. How to give other user access to your Kubernetes cluster, all right? To your Kubernetes cluster. So I'm going to edit this file. See this file, this AWS auth. We're going to edit it. Or what we'll do, we'll create a new one out of this one. So this is what we'll do. Let me go out. This is what we'll do. So come here and say kubectl gets config map. So I want to get this particular config map. Config map AWS auth. AWS dash auth. This is particular guy. Now, I want to check the YAML. OYAML. The raw configuration of that file. OYAML. This is the raw configuration of that file. Guys, watch you sitting there happen. I will redirect this file, this content into a new file. I will now say redirect into AWS auth new.yaml. I will not go into that file, AWS auth new.yaml. I've gotten the file now. I will now add the user that I want to add to the same configuration. So I have a separate block. All right, I'll add the same user. Once I add it, I will save and quit. Then I'll say waiting, kubectl apply -f AWS auth. It's going to create a new, what's it called, config map. All right, a new config map in that kube system namespace. Okay, but when we get there, let's not digress.
Got it.
It's a full topic. It's a full
But
topic.
UID will be getting into that new manifest.
Sorry?
I mean the UID of the new user you're adding will be taken into the new into the new manifest that you're. That's great. Okay, got it.
Yeah, right. So today, okay, what we're talking about today is where's that guy now? 7 dam. All right, so we're going to be looking at replica sets. Replica sets and the rest. All right, same thing, guys. Same thing we did yesterday. All right, so like I always mention, replica sets was discussed under the Kubernetes objects. All right, so what we're looking at is how to write replica sets. Guys, is simple, straightforward. And Atiku, you do my assignment.
Boss, I no do am.
No do one.
I
No
was
do one.
fully engaged, honestly.
All right. So now, all right. Before I come back here, let me show you something. I'll go to my cluster. This is my cluster, right? Change to K8. Today is something different. MKDR. Let me call it message. MSG. Go into MSG. Empty. Now I want to create, it's very simple, guys. Simple thing. I want to create a what? An active MQ. This is what I'll do. I'll just copy what I have here, pod, into active mq.yaml. So I'm copying this content into this guy. Copy. So I'll also copy service. Do I have service there? Okay, ecom service to how do I do this? All right, so let me do it like this. Let me cut pod into active MQ, then cut what? Cut ecom service into active MQ. Now we have active MQ, right? So let me go into that active MQ file. So now what do I have here? So I have this first definition as a pod and it ends here, right? Now in YAML, there's something called document separator. So document separator is 3 dash. This thing means document separator. So I'm separating this document. This document is one document from this other what document. So going forward, we will be writing all of our objects, all of the objects you'll be working with. You write it in one single file. No need to be writing multiple files. No, just one single file, but you're going to separate them with what? A document separator. Take note, guys, right? So this is a service for ActiveMQ. So this is what I will do. I'll come here, the namespace, I'll keep it default namespace. I'll keep it in default namespace. Or while you're on camera, I'm just going to play with that. I'll keep it in default namespace. And the label is AMQ, all right? App AMQ. Then the name is active MQ. Okay. Name is active MQ. Then the image, this is what I will do. I'll go to Google. I'll say Docker active MQ. Guy, look at the official image. Do we have it? There's no official image of ActiveMQ, but let's look at this first link. Let's look at this first link. ActiveMQ is written by Apache. ActiveMQ Apache. Where is the Docker image? Docker images. This is their official Docker images are available on Docker Hub. Let's check. Let's check. Who is this guys? Okay, ActiveMQ. Let's check. Official. Well, let me check. I'm not seeing anything on classic. Let me check this. Let's check what we have here. Okay, this is official now. Open sponsored OSS, open source OSS is open source meeting guy. OSS. OSS. Open source standard. The meaning of OSS is open source standard. All right. So open source standard. Let me check this other one. So this is classic. There's nothing on this classic. Apache ActiveMQ classic. Apache ActiveMQ waiting. Ate. So I copy this image. All right. Come to your manifest. So paste it here. Paste. Artemis. So guys, then I don't need this port. I don't need this session. Remove this guy because ActiveMQ runs on a different port. So leave it as it is like this. Then the service, I'll call it, the name is AMQ SVC. Namespace is default namespace. Then selector is AMQ. Then ActiveMQ runs on ports. There's a port ActiveMQ runs on. Port number. Ports. Let's check. 8161. So now there are two ports. This will start the ActiveMQ container and bind the default ports. 6161.6 for JMS and 8161 for web console. So for web console is 8161, right, to the host machine. You should see the ActiveMQ container. Let me look at what they've done here. Let me look at what they did. Let me also check here. Let's check ActiveMQ. Where's the port number? Okay, 8161. So I'll come over here. So the service port is 8161. All right. 8161. Okay. So I'll use a node port. Then type is node ports. Great. So escape, save and quit. Let's apply. kubectl apply -f ActiveMQ. So it has created a pod. It has also created a service. Now let's check kubectl get pod. So it's still container creating. Let's check. Now it's why is showing Feedman? Let me go back to that file. ActiveMQ. Oh, the name. So it has to be ActiveMQ. ActiveMQ. Escape, save and quit. So kubectl apply -f this. Created. Now kubectl get pod. So now it's going to, let's see. It should destroy one, but it's not destroying. So let's manually destroy because the name has changed. So I'll say kubectl delete pod, the pod name. Pod name is what? Fleetman dashboard. Deleted. So if I say kubectl get port, I only have this guy, right? So now let's go to our browser. Let's check on which node this guy is running. Oh, wide. So this guy is running on this node. kubectl get node. Why am I getting only one node? kubectl get node. All right. So this is running on 2.255, right? 2.255. So all right. So let's go to our console and check which instance is that public IP.
2.252.
Okay, 252. Let me check this. 2.252. So copy that is the public IP. Copy it. Go to your browser. Go to your browser. Column 8161, right? 8161. Let's see. There's a way we should set this guy. Come on. So we'll specify 6161. Internal ports. 8161. I didn't take run. Okay, we have not exposed that port. We've not exposed that port, guys. So don't forget, guys. All right. So go to security group, security. All right. Actions, security, change security group. So let me add my own security group. Frank SG. Don't forget, guys. So add security group, save. So once we save, come back here. This should, let's see. Why is it not updating? 8161 now. 8161. It's not going. Let's check. Security group. Where is it now?
I think you might need to create a rule, new rule for
Create a what?
rule under the existing security group, maybe.
No, I have everything open on this guy.
Open. Okay.
Yeah. I have everything open. So I think we're not targeting something. 8161. 8161. So let me come here now. Let me come to the manifest. Come back to that manifest. So here I will say port. Port is port is wait to ports, then container ports, right? So let's go there. Container ports. Ports container ports is 8161. Then target port is 61616, right? 61616. 81, okay. 61616. All right. Because it has two ports. One is for the web interface and this other guy. So let's check. Let's save it. Target port. Let's save this guy and kubectl apply -f ActiveMQ. Whoa, 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 whoa. We're not targeting this guy where ports cards And now container ports then S under name. Eight 8161 target ports. Right, let me remove this part. Save and quit. Apply. What of this may not change fields other than spec container image? Or let me delete it. kubectl delete -f active delete. Let's recreate it. Apply. Okay. So let's refresh. Let's check. kubectl get pod is running. Refresh. Let's check the logs. kubectl logs active MQ. Sorry. Active MQ. So the log says this. HTTP server started at 8161. And now why is it not coming up? Console available at this guy /console. Okay, /console. Refresh. So I'll say /console. Still not going through. /console. Voice server is disabled. Six one six one three 6161. Okay, let me check one more time the logs. I'm not finished. 8161. Wait, let me check the service. 1 second, guys. Active. Sorry. Fuck. Sorry, guys. Sorry.
Enable the notepad, I think.
I had to go use notepad. Wait. Okay. 32,000. 32,000. Enter. So now what I supposed to do since I go do something else. I forget say I use a notepad. All right. Because we need to access it externally. So that's why we're using this notepad. So this is your active MQ. So the username is it admin? Then admin. I'm not get the password. All right. So this is what I was expecting from you guys. All right. This is what I was expecting from you guys. All right. So I won't be doing your assignments. So take note, guys. I won't be doing your assignments. You have to try. So now ReplicaSet. So ReplicaSet is an upgrade to what? To a pod. It's an upgrade to a pod, right? Like we said, ReplicaSets, they have long life. Okay, so in production, you won't be deploying pods. Rather, you'll be deploying pods through deployment, StatefulSet, Daemonset. All right. You won't also be deploying ReplicaSet, but we need to show us what is ReplicaSet. Okay, so great. So now let's go to Google. Simple. Go to Google. Our normal way. Say what? Kubernetes, then ReplicaSet. Simple, straightforward, guy. You always get the documentation. right click and open a new tab. Here it is. All right, scroll down, scroll down. This is your manifest for ReplicaSet. This is a manifest. So copy it. So I'll show the difference between a ReplicaSet and a pod. Now let's go here now. So I want to create a file called RPS, replicaset.yaml. So in this file, I will paste this guy. Now look at this guy now. See you. A replica set is much more different from a pod. Now, a replica set has a specification for templates, right? I'm going to explain. It has a spec for templates, then it has a separate spec for your container. Now, this is the difference between the pod. The only difference between the pod and the replica set is this section. Every other thing is the same thing as a pod. This part and this part. Let me put the line numbers. Now, from 8 to 17 is what is being added, right? So aside from 8 to 17, every other thing is a pod definition. It's a pod word definition. So let's get started. So you can see the API version has also changed. The API version has also changed from V1 to apps/V1. All right, great. The kind is a replica set. This is how it's defined. Now, the metadata is the properties of that object. So I'll call it, can I remove this guy? What should I call it? Which I call it, which application is this? I'll call it ecom. Let's say ecom. Then label, I can say app ecom. Then I don't want this other label. You can leave it. You can leave it. See, you can add multiple labels, guys. Multiple labels. Then specification. Now you need to define how many number of pods you're going to create out of this replica set. Out of this replica. So that's why you're seeing these replicas. So these replicas means 3, meaning that I'm going to create 3 pods. This deployment, sorry, this manifest, this replica set manifest is going to create for me 3 pods at once, right? So it means that at every instance, at every point, it is only 3 replicas. It's only a minimum of 3 replicas. It is only a minimum of 3 pods that will be running in this cluster for this guy, for this particular application, right? So if I try to delete a pod that is deployed through a replica set, the replica set controller, the replica controller is going to recreate that pod to make it 3, meaning that at every point there must be 3 instances of this application running, right? So I say 3. Now selector match labels. Match label has to be the same thing as what you have here, all right? Take note, guys. So I'll come here and I'll say app column ecom, then template labels app column ecom. Now this is what's happening here. Selector aside service, the only place you can use selector again is when you are defining your specifications or your replica specification. All right. So this selector is going to, it has a subfield called match labels. This match label has to correspond with what you have on top of labels, right? Match label has to correspond with what you have under here. Then we have another field called the template. So template is a kind of you're kind of mirroring whatever you have over here. All right? You're mirroring whatever I have over here. That's template. And that's the flow. That's how it should be. Then this last part is the specification for the image. For the image here, I'll be using my ecom. ecom, then the image will be Frankie's info tech slash Apache demo. That's all, guys. So I need to define the service as well, right? So dash 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 document separator. So let's go and copy a service. So cat this guy. Let me copy this service section. Copy this guy. Copy. Copy. Go back to that RPS. All right. So I'll paste the service. So I'll define the service. The service is ecom SVC, ecom SVC. Then app selector, take note, guys, it has to match with your matching label, right? So it has to be app, then ecom. Then the port number, the port of this service is port 80, all right? So I'm going to be accessing this guy on 32200. The service type is a node port, right? So that's okay. Escape. Or if I'm not even going to access it. All right, so no wala. Save and quit. Now let's apply. kubectl apply dash F RPS. So this guy is going to create for me 3 ports. So if I say kubectl get port, you see that I'll have e-commerce. It's a error image pool. Is having an error trying to pull that image. Is it the name? Is it the name?
Yes, the image name.
Apache
Need to put V1.
Okay, V1.
Yeah.
Okay. I didn't put V1. Column V1. So that's why we're having that error, right? So I'm going to reapply. kubectl apply. Now let's check. kubectl get port. It's just now V1. Okay. Let's check. Okay, let's see. Image pool back off. We're having just now V1. kubectl, sorry, Docker search Frankie's info tech / Apache demo V1. Oh, I never start the service. System sudo systemctl restart Docker. Search. Are you sure? Okay, I don't see one. Apache demo / Apache demo. Apache demo. Is it V1? kubectl get pod. No. Frankie's Infotech Apache demo. Vim. It's V1 now. Frankie's Infotech Apache demo. Wait, to
Maybe you should just delete it and create it again. Maybe.
kubectl get pod. kubectl apply dash F. RPS get pod. Get pod. It confirms in a V1.
Yeah, I'm sure. Now V1.
Okay, let me check Docker Hub. Google Docker shirts. I need to see my image now. In the mad. In the mad, I need to see my image. Wait, to Docker pull. Okay, let me do something. Docker pull this guy. Docker pull V1. V1 now. So Docker images, what the challenge? Docker images, RMI, remove the ID. Docker images, RPS, V1, save. kubectl delete -f, RPS, kubectl apply -f RPS. kubectl gets port. Container creating. All right, thank you. Thank you, man. All right, so this guy is now running. You can see because of we have set what 3 replicas. Okay. Now, if I delete any of these guys, so if I say kubectl delete, sorry, kubectl delete pod, then the pod name. Let me say, let me delete this guy. Now, if I say kubectl get pod, it's going to recreate that guy 5 seconds ago. It has recreated a new, it has spin up a new pod because we've told the controller, we've told in our manifest, we've said it that this manifest should create a minimum of what? 3 pods out of the replica set, out of the object. We have here RPS, right? So this is it, 3 replicas. So it means that at every point, there must be 3 pods running in the same name. So this number of replicas are needed for high availability. For high availability. So now if I now check kubectl get pod all wide, let me check the node which they are running on. So you can see this is running on this other guy 2.252. All right. So I can access this guy on either of these nodes. All right. So let's go 2.252. What's the port node port? 32200. So I'll go to my browser. Where is that place? That IP address was what? The IP address was this guy. Go over here, paste it, column 32200. So this is going to display for me my website. Similarly, if I take the other guy, where is the other guy? The other guy is yeah, this is the other guy. So it's 34 this. If I come here, paste column 32200, it will display the same thing. Let's watch, it will display the same thing. So let's come here. Why is 32200? Why is it taking time? So one of these is running on this guy now. Maybe this. Why is it not coming up? Okay. We have not added the security group, guys. To this guy, go to security group. You can see it's empty. So come to action. Don't forget at any time. Security, change security group, add Frank SG, add, then save. The moment I save, this guy should update. It does not update, just watch. of the node time. Column 32,200. You can see it has propagated. So on these two different IPs, I'm accessing my applications, right? Now it means that what's going to happen is if either of the node goes down, if either of these nodes go down, right, the queue scheduler is going to schedule all of my ports on the node that is active, right? So let's demonstrate it. Let me delete one of those nodes. Let me come here. Let me delete one of these nodes, right? This guy. I'll come here. I'll say terminate. Terminate. Refresh. Now, see what's going to happen. I'll say watch. Sorry. kubectl get pod -w. So -w means to watch. Let me say watch o wide. Let me see if this one will work. All right, it's working. Now, see, one of these nodes now will go down. See, I'm terminating 116. I'm terminating 116. Look at now. See what's happening now. Now, this guy is trying to reschedule. He's trying to reschedule. This cube scheduler is trying to reschedule the active MQ that is pointing on 116 on a new node. Let's see. Let's see what's happening. So I'm watching what's happening. So you see that there will be a new node with a new IP address. Now this guy is shutting down. It's completely down now. It's terminated. Let's check now. Has any new one been spun up? There's no new one yet. There's no new one yet. Let's check our terminal. Let's keep watching. This guy is watching. Let's wait. You see what's happening? So let's refresh. There's no new one yet. It will soon come up. So the moment a new pod gets registered, the cube scheduler is going to schedule those pods on those nodes. Currently now, what's happening here now is all of these pods are being scheduled on 2.55. Look at see now. See now. See what's happening. See what's happening. See what's happening. So it has terminated 1.116. All right. Then rescheduling is happening now. Rescheduling is taking place. Let me open this thing now. Rescheduling is happening somewhere. So this is how this thing now is recreating these pods on a now you can say it's now rescheduling this pod on this 2.255. It's rescheduling everything now on 2.255. It's terminating all those pods that were on 1.116 and they are now being rescheduled on a new node. While they are there, all right, they will be there running until a new node gets created into the cluster. Then the cube scheduler will now use its algorithm, all right, to reschedule those other ports on the other nodes. All of these is necessary because of high availability, to maintain high availability. Let's see what's happening, right? So to achieve high availability, because you see, I'll keep on refreshing this guy now. I'll refreshing. This guy is still on. But if I refresh this guy now, this guy is off. This very server is off because of the node is down. But this other node is still serving my application. So my customers, they will never notice if there was any downtime. But internally, there was a downtime. But because of we try to set up a high available system, the customer will never experience that downtime. all right? Because we have two we have two worker nodes. One is down. While one is down, the other, while one is down, the kube scheduler has already rescheduled the ports on the other node that is up, all right? So that node will be serving the applications. So nothing will happen. So customer will not notice anything, right? It is only you as a system admin who have noticed that something went wrong. So let's check our instance. Refresh. Let's check. So there's a new node now. Look at now. There's a new node in the block. What's the IP address? The IP address is what? 1.251. This guy now. Now let's check our terminal. Let's check our terminal. Let's check 1.251. You should see it somewhere. Just wait. So it takes time to reschedule and all of that. So let's just watch. So this is the whole gist, guys. This is the whole gist. This guy is completely dead. It's gone. All right? It's gone. So this is a new guy. All right? So this is what you experience under the hood. Okay? Let's wait for that guy to be assigned. I don't know why it's taking time. I don't know why it's taking time. Come on. So while we are waiting for this guy to come up, we need to see it. We need to see it's very necessary. All right. So this was ReplicaSet. All right. ReplicaSet. Okay. Now deployments and StatefulSet, they are going to take the same shape, the same manifest. All we just need to just change is just the name, the kind is the same thing. All right. So we're almost done. Let's see. Let's just wait for this guy to come up. Let's just wait for this guy to come up. Oh boy, my system they catch fire. System's catching fire, guys. Come up now. All right, let me terminate and do it again. Kube gets port, watch all wide. Let's see. All right, so it has not. What's happening here? What's happening here? Okay, it is only 2. All right, it's only 2.255. So all of it doesn't reschedule this guy ActiveMQ. It terminated ActiveMQ. So it takes some time, man. I don't know why. It takes a whole lot of time. It's taking a whole time. You know, like you can see all these ports now, they are now running only on this node. So this other node is not yet available. Why? All right, it should be fine now. Check pass. Let's check it now. Let's check it. Come. All right, so let's not waste much time. Suppose come here. So kubectl gets port. It has evicted that what's it called? The ActiveMQ, but it's going. Oh, the ActiveMQ was a pod. It was deployed as a pod. It wasn't deployed through a replica set. That's why its life is not it dies easily. You can see it. It dies easily. That's gone. It died easily. All right. So a pod dies easily, but a pod that is deployed as a replica set or a deployment has a long life. It doesn't die. Okay. So great, guys. Great. Now we have seen replica sets. Let's now look at deployments. So all I need to do, I'll just need to copy this guy. Copy replica to deploy.yaml. Now go into this file, deploy.yaml. All I need to change is just the kind, guys, deployments. Okpari. Every other thing remains the same way it is. Every other thing remains the same way it is. Let me change the name. Let me call it ecom deploy. That's the name of the deployment, right? Then the app is ecom app, ecom-app, right? Then ecom-app, ecom-app. Container name is ecom deploy. Then the service is this, okay, ecom-app svc selector ecom-app, right? So the port is I can use maybe I use Nginx in this time. I'll use Nginx. So the node port is 31200. 31200. So my image will be Nginx. All right. So Nginx, I'm deploying Nginx. So the number of replicas, I need to keep it as 1. All right. Save and quit. Now kubectl apply -f deploy. So this deployment has been created. So what I'll do now, say, well, kubectl get deployment. So get deployment, I'll have with 1 deployment. Now kubectl get replica set. So you can see now, I have replica sets. See you. Inside of this deployment, I'm also creating a replica set. So this deployment has a replica set called ecom deploy. This is a replica set that controls this deployment. Because in this deployment file, I have defined that how many replica, I just want only 1 replica. So this guy is controlled by the replication controller, right? The replication controller, right? Which replica set comes from that controller. Okay. Now I can also say kubectl get deploy, which is get deployment. So currently I have this deployment. Now what this thing means is that 1/1, up to date 1, available 1. So it means that my deployment is active and it's up and running. Now look at what we have here. Under replica, I have desired 3, current 3, ready 3. It means that out of the desired number of replicas that I defined in my manifest, 3 of them are currently available and 3 are ready. They are running. So that's why if I say kubectl get pod, I'm going to see those 3. Yeah, those 3. This is the replica set. Then this is deployment. Now, CO, look at the name deployment. Look at the name the pod is inheriting from the deployment. Now let's look at of the replica set first. Let's get replica sets. Get replica sets. This is replica set. You can see that this is the name of the replica set. That's the name of the replica set. Now let's check deployments. Get deployments. This is the name of the deployment. Ecom deploy is the name. To get the name of the replica set, the replication controller is adding random value here attached to what? The deployment name. And this becomes what? The name of the replica set that is deployed through the deployment. Now, to identify the pod that gets created out of this deployment, Where's the pod? This is the pod. So the pod will carry the name of the deployment, followed by the replica set, then a random number. So this part is a part that defines the pod. So the complete pod name will be ecom deploy this number and this number. To identify where these numbers are coming from, this naming convention is coming from, this first part is the name of the deployment. This second part is the name of a replica set. And this last part is the part that defines the pod. So the complete name of the pod is this. So if I copy this guy and now say kubectl get pod, the pod name, which is that name, I'll get only that guy. You can see. So this is the pod name. Now, if I delete this pod, kubectl delete pod in the pod name, this guy will recreate itself. Now, kubectl get pod. If I check now, new one has been already created. Check, the name has changed, but the replica set name does not change. Just the name of the pod that changed 5 seconds ago. This guy will never die. This pod can never die. If you delete it, it will recreate. It will never die until the deployment that controls that pod is deleted. So if I come in and say kubectl get deploy, I want to delete this deployment. kubectl delete deploy, ecom -deploy. Then everything about that deployment is gone. If I say kubectl get pod, you can see it's all gone. It's all gone. So this is the whole story, guys. This is a whole story. So we have seen what? We've seen replica sets. We've seen deployments, right? Now we're going to see StatefulSet before we see a Daemonset. StatefulSet. So now I'll go back to my manifest. I'll open my manifest. Check. I'll just copy deploy to ss.yaml. All right. Now go into ss. Now I'll just change the kind from deployment to StatefulSet. That's all, guys. Ecom ss. I can say ss ecom. That's the name of the StatefulSet. Then ss ecom app, ss ecom app, ss ecom app, ss ecom, ss ecom. The name is ss ecom. Then the service ss ecom app svc. Then ss this port 80. So change node port. Node port is 33200. Escape, save and quit. So how many replica? So let me do 2 replica of these. 2 replicas. 2 replica of 2. Let's save and quit. Now let's apply kubectl apply -f ss. What is saying? Invalid port number. Provided port is not in the valid range. Okay. 33 is not in the valid range. So let me change it to 32. So, okay, see, this is the valid range, guys. All right. From 30,000 to 32,767. So 33,000 is not among. Take note, guys, or take notes. 33,000 is not among the valid range of node port numbers. All right. Me, I'm just saying it now. I did say before, everything follow. All right, so come down here, service, and let's rephrase this guy. All right, so 31,100. So 31,100. So let's reapply. Created. Now kubectl get pod. Now look at this thing now. Look at this is the pod that is created from the what? The stateful set. Okay, I've deleted that deployment. kubectl apply deploy. All right. So kubectl get pod. Let's see everything. So you see the difference between a stateful set and a deployment. So like we mentioned in our Kubernetes objects, that class that day, we said the difference between a stateful set and a deployment is in the naming convention. A stateful set uses what? Indexing. So this is index 0, index 1. If I had 3 replica or 4 replica, let me go and increase the number of replicas of my stateful sets. Let me say 5, right? I say 5, kubectl apply -f ss created. Now kubectl get pod. Now you can see I have, these are indexes 0, 1, 2, 3, 4. This is how stateful sets identifies the pod. This is how deployment identifies the pod. So both deployment and stateful set, they use replica. So if I say kubectl get replica set rs, what is replica here? Why is not kubectl gets stateful set stateful set econ. So I'm not getting replica. I'm getting replica. All right. Okay. All right, let's continue, guys. So you can see, all right. So if I try to access this guy on the browser, so any of this IP, this is the service is kubectl get service. Service is node port. Stateful set is what? Where's stateful set service? This is it. 31,100. So I'll come here. This is my IP, right? I'll say 31,100. Remember, I use Nginx. So this is the Nginx image. This is the Nginx site I am getting. All right. So this is the whole story, guys. The whole story. So the last but not the least is what? Is Daemonset. So with Daemonset, I don't need to specify replica. So let me copy ss to daemon.yaml. So I'll go into what? Daemon. So in this, I'll say Daemonset. I'll call it DD or DS. We don't need replica sets. All right. So this guy is going to create 2 replica automatically. Because what is a Daemonset again? A Daemonset ensures that the node runs a copy. All the nodes run a copy of your application. All right. It ensures that every worker node runs a copy of your application. That's what the Daemonset does. So let's come down here, change the label to DS, and DS, change port number to 3200, then 3200, then let me change the image. Let me use some image here. Let me use this image. Copy. Paste it. That's it. Escape, save and quit. Now let's apply. So kubectl gets pod. I'm going to have two replica of this guy running. So what I will say, I'll now say kubectl apply -f who Daemonset. Right? So no matching for kind Daemonset in version. Is it daemon? Okay, I go put E there. I go put E. So I go put E for here. Since there's no matching kind, Daemonset. Now let's reapply. Apply. So this guy has been created. Now let's check it. Keep still get pod. Now see now. It's creating automatically two replica because I have what? Two worker nodes. So it's going to create a copy of this application on each of these worker nodes. Now let's check O wide. Now you see that. Why am I getting error now? Guys, see now, this guy is running a copy. This other guy is also running a copy. Why am I getting error? Keep it a get pod. Crash loop back off. What's the challenge? Let's check. kubectl logs, then the Daemonset name, the pod name, sorry. What are we getting? Okay. This image requires environment variable. All right, so notwithstanding, guys, okay, environment variable need to be set for this image to work. Spring profiles active. So let me check what I have here. So I need to set environment variable, okay, for this guy. So now let's update, copy. Let's update our manifest, Daemonset. So on that specification, I'm going to add another field called env. All right, so these are use environment variable in your manifest. So name, then value. So that's it. Escape, save and quit. Let's reapply. kubectl apply this guy, created. Now let's check now. kubectl get pod. So this guy should work. Let's see. Get pod. See showing crash loop back off. See, let's delete it. kubectl delete -f daemon. Recreate it. Apply. Now kubectl get pod. Still showing error. I set the environment variable well now. Environment variable value production microservice. Bim. profile active on the pod. Vim daemon. Oh, sorry. Wait though. And another containers now. So what's there now? Spring profile active. Spring profile active. Specification. No. Because if I go like this, you throw up an error. You throw up an error. Apply. You throw up an error. It's a wrong indentation. So it has to be here. Apply. QCTL gets pod. All right, guys. So that's it for today, guys. So when we meet on Friday, we shall be building, we shall see how to build a microservice, how to deploy a microservice application. We're going to see different components. All right. But let me change this image. Let me change this image to something else. To 0. All right. Apply. Now keep the get pod. Get pod. All right. So now I have a workable image, right? So I can access this guy now on the browser. So let's check all wide. So any of the IP address, either 255 or 251 is going to serve. All right. So I'll come here. What's the port number? The port number is QCTL get service. SS Daemonset. DS Daemonset. 3200. All right. So come over here and out of these guys, 3200. Hit enter. So we're going to have, oh, this was the old node. Sorry, guys. This was the old node. I can duplicate this guy and I'll come over here and say 3200. Enter. So this guy is going to run my new Daemonset application. So that's it for today, guys. Is there any question? Is there any query? So these are our application now, up and running. Is there any query? All right. So since there's no query, I would love to bring this session to a close. And I want to see you guys on Friday. Basky. Basky now. Article.
Too hot.
Brother. What's it going to do now? The idea make una catch up. You get me? Just catch up. You know? So when we come on Friday, because we have a plan, we shall start off with deploying a microservice application. Right? This will be from 11. Microservice architecture. Shall look at it and deploy all of these components. They are components, all right? Then we shall now be progressing gradually. We shall look at persistent volume, all right? Then also look at logging and monitoring, okay? Then cluster, monitoring Kubernetes cluster with Prometheus and Grafana, monitoring cluster with Grafana Cloud, Kubernetes request and limits, quality of service, horizontal pod auto scaling, config map and secrets, ingress controller, Kubernetes arrowback, continuous deployment on Kubernetes. This will come after Jenkins, all right? We shall revisit this guy after Jenkins. introduction to YAML, and goodbye from Kubernetes. All right. So that's the whole picture, guys. So let me stop recording since